I want to comment on it. So in the lower part, there is a series of graphs which was detected by Mr. Schuler. This is a life cycle of technical systems from curves from this shape to another. So it shows the changes of the systems for the infillment with new life, with new transformation. And in my understanding, that very period of 20 years, which we celebrate, uh, it has its own changes as well. So, uh, of course, all today's speeches, they broaden this historical moment when it was connected only with technical side, but also spread the variety of range of inventive tasks. So the world is being captured by the theory of inventive tasks, and today's conference, with the participation of our colleagues from other countries, it has its own input. So everyone who touches trees has this inner feeling as if it is some magic touch. And the symbol of this idea, common principle or idea, is a lamp, bulb. And so by touching it this way or another, it gives you some results. So now this field is broadened, and TRIZ gives opportunity to enlarge the sizes and the quality of lighting and of light and all the techniques, all the technology. And of course, it is so pleasant that we get new tools for those people who accept it, who develop it, who perfect it, and who share their impressions and findings and ideas with their colleagues. So that's why I wish us all to continue this activity of Mr. Schuler. We celebrate 98 years from his birth. So let his activity inspire all of us and give some ability to all of us to personally grow and etc. So my topic is a trend of automation development in current and future technical systems. So briefly about what I wanted to talk about tendencies which is directed, which is related to automation. This automation was started a long time ago, and it requires separate study, because if we talk about theory of uh, technical task, we can talk about Greek term "sam," so it means author or author. So that's why when we predict some actions by tree specialists together with current tasks and formation of the future tasks. So I give you my vision and understanding. What does it mean, automation? So there are some authors and specificities, and in the context of my talk, automation is a stage of scientific and technological progress aimed at increasing the efficiency of process without human participation. So that's why all my report will be based on that concept. And I give you the quote of Steve Jobs. It doesn't make sense to hire smart people and tell them what to do, but we hire smart people so they can tell us what to do. So if we talk about theory of inventive tests, there are some laws of development of technical systems. There are new visions, new imaginations, perceptions. That's why those heads as Steve Jobs will be relevant to the saying. So then new workers would come and they would suggest their perspective ideas. That's why I would like to show you the tool by which we can offer perfection of different technical systems. So basics is the quote of Mr. L. Schuler: technical systems are developed in compliance with objectivity of existing principle. These principles are recognizable and can be discovered and used for continuously solving inventive problems. So his analysis gave us ability to create three groups: statics, kinematics, and dynamics. All who are present, you know about that. And what's new, what I want to tell you and show you, it's the private approach, I would say, as per understanding of the vision, as of the target object of labor in relevant actual condition. So at first, definition of the term technical system, there are a lot of those definitions. It depends on the standpoint and how you would put it, how author would put his own information. So for today, I would say that is a man-made tool or tool assistant. So it is assistant, it should be a helper to stay as an assistant, facilitating achievement of the set goal. So here we say facilitating or helping. So it's like a method. So when we project some system, so we create some method how to achieve it. So we have some demand and we achieve it by achieving some goal. So at first, this goal is virtual in our imagination, and that message which is put by the person, I would like to have it, I want to have it. I don't have it now, but for example, I would like to have some wood for some purpose. If this would be ready, well, that's good. You can have it, but not often that ready-made product is sitting and waiting for you as a final goal. Well, if it happens, so then kind of it will be taken by somebody pretty fast. So that's why we have to get some target object, and it will be some kind of a resource by transforming which we will achieve that expected result. So I call it target object or the subject of labor targeted by TS, technical system. So that very object has current actual status, condition, which is unsatisfactory for us, or it is satisfying us, but we want to keep it. So the word changes or transformation, it means that we can expand or decrease some parameter. So in that very time, we have such pieces of wood, such logs, chucks, and they are not fitting the final result. So how to achieve the result? You can get some technical system, it is ready or it will be developed. So actual condition of this subject of labor or target object should be transformed in the consequent action to get desirable result. So initial condition of the target object, it doesn't matter which, is it iron or wood. For example, our goal is to have minced meat, farce, and we have big pieces of meat, and to one of the means how to achieve it is to have special mincing machine. Or for example, we have to get some painted colored fence. It should require, it requires painting. So to use it, we have to get some paint spray. So technical system interacts or influences the target object in some actual condition to get desirable results. So I call it basic functions of technical systems. The concept of functions is different at every company. Some methodology of explanation is different. So if someone's interested in that, uh, so we can change the variety of those functions. We can discuss it. I understand myself. So there is some target function of the technical system, which is directed on the achieved goal. And there is a working function where engineer put some ideas, some functions. For example, we have such elements. They are all directed to resolve the question, the test. For example, we wash our hands and it's according to hygienic rules. So water is still in our palms, in the wrinkles of the palms. So if it's okay as per humidity of hands, so that's okay. But bacteria could stay there. So we have to do something with this moisture in it. So actual condition is we have humid, wet palms, but we want to dry hands, right? So everyone has his own require on the level of moisture on his hands. But finally, we shouldn't change our hands. We have to change actual condition with what it is connected. So all those drops of humidity should be removed. And it could be removed by different means, but we use special means to achieve the target. So we have the goal and how to act on it, how to achieve it. So we take some technical elements, some systems, and they influence our hands. So they don't change target goal, target object, but they change its actual status. So what kind of principle is performed there? So if requirements are increased and it happens constantly, so then other systems in the framework of new requirements will be used, but they are different as the principle of action. So the goal is the same, but the means of achievement is the same. So if we have goal setting, right, goals, so we can get alternative system for achieving this goal. So that's why evolution happens. We can track tendencies, trends, and on and on. It's a different topic, separate topic. And that scheme which I use, technical system, and its target function is determined by the result. So it has this target function for which this target system is created. There is a object which should be influenced by technical system and how to achieve that goal. And so we change this actual condition.
We say that this is a perfect system. We do not assess the way it has an impact, but the result. No one is interested how much you slept. The only thing that is of interest is the result, the output that you're getting out into the external world. If it is not satisfactory, then you need to apply some other assessment. So, when working on some technical system, you can ask why do you do that? If this is not understood, well, I'd say that this is the worst situation possible because the work is done for the work without any understanding of why this is done. So here we have impact on the moist hands. What do we want to get? We want our hands to be dry. So the idea is to dry the hands off. Then the question is how to do that. Now we are looking into specificity, into specific methods that can do that. For example, we can use a towel. Towel can indeed get us to the end result of having dry hands. If we have on to the English version of the slide, well, you can see it, then if you're using a fan, basically you get the same. The target function is the same, and the result you're getting is the same. Basically, uh, everything is the same, but the only difference of method. So the fan cannot take in, absorb the moisture. It can only air it off, blow it off your hands. So that is it. The idea is about the target function, the required action that the technical system needs to perform. And the method is about the way it is done. So now let us go into operating peculiarities of technical systems so that you understand very well what I'm talking about. So technical systems got invented not for nothing. That was to make sure that we can get the desired result using specific methods and going through performance of target functions. For example, in the case of a pump, which is a technical system, we have some tank, which is the object of our target function, and the idea is to fill this tank with water by supplying water into that tank. Um, so we see a quite a peculiar situation here. The target is met. The tank is full of water, but the pump keeps on supplying water, more water into the tank. However, the target result is already obtained. The tank is already full of water. Now, let us talk about the central heating. So, central heating system uses heaters installed in the rooms, and in this case, the object is a cold room that we want to heat up. And we need to make sure that the heater can generate some heat that can take the actual state of the room, which is cold, into the warmer condition. And in Russia, It is quite a common situation where the target is already achieved. That is, the room is already heated up, but the central heating keeps on heating up the room, keep on performing its major function, and this results in ineffectiveness of the system. One more example. Let us consider a lantern. Lanterns that are installed in the streets to keep the streets lit during the night. But then comes the day, and it keeps on lighting the streets, and in massive amounts of funds are spent lighting the streets like that. That is when designing such technical systems, we see that there is some change ongoing in the external world, and this change keeps on reproducing itself. That is, technical system keeps doing its job after the end result is obtained. For example, people watching TV fall asleep, but the TV set keeps on working. So the conclusion is that if we no longer have the object to have an impact on, or the target result is already obtained, the further work of the technical system is ineffective. It is unnecessary. Meaning that the technical system keeps on operating in vain. So how can we overcome that? So the analysis of the examples I've shared with you show that if we no longer have the object, we need to stop the technical system performing the function. That is, we have a list of criteria that defines how a more effective technical system would operate. For example, we can have some sensors to obtain some feedback onto the technical system. I'm not saying that such sensors can be available everywhere, but this is one of the options to overcome that. And if we deal with a technical system which doesn't allow for its improvement, we can have recourse to automation. For example, we have water taps that only work if there are some hands below the sensor. Soap tank that supplies soap only when the respective sensor is activated, or a towel which is supplied only in case of the availability of the object that needs that towel. In case of a vehicle, we have a parking system that makes it possible to take feedback from the environment, analyzing whether we need to keep backtracking the vehicle or not.
руками это открывать, да, уже автоматически уже багажник сам будет открываться. Автосигнализация, там, распознавание дорожных знаков.
Also, signaling system of a vehicle, night vision,
уже заложенных элементов, которые
identification
все
of
больше и больше будут
road signs, etc. So today, our vehicles become stuffed with such systems which provide for more effective operation of the vehicles.
Здравствуйте, 3 минуты до окончания.
Да, да, спасибо,
Uh,
я как раз успеваю.
Sorry, there are 3 minutes left.
Сейчас я просто пролистаю.
So we have a lot of
Все то, что у нас используется, они тоже выполняют
kitchenware and furniture examples that show that represent more effective technical systems. So first, technical systems are developed based on automation. Second, one of the causes of using automation is that the technical systems are designed operate ineffectively.
как текущих технических систем, так и будущих систем при проектировании. Вот, базовые функции, понимание базовых функций.
The better understanding of basic functions of technical systems make it possible to design technical systems in a more sensible way. And then we have specific examples where we show that the criteria showing that we need to make some changes to newly designed systems are met. Thank you very much for attention. Would be happy to answer your questions.
Времени очень мало.
Indeed, we do
В
have
принципе, я
questions,
озвучу один
but
первый
unfortunately, we
дальше
are
можете отвечать уже в чате.
short of time. I'll voice only a couple of
Есть ли
questions.
отличие между вспомогательными функциями функционального
Is
анализа и рабочими?
there a difference between main operating functions and auxiliary functions? Yes, of course. The main operating systems is the basic function that makes it possible to implement the target function, and auxiliary functions are just helpful in achieving that goal.
Спасибо. Ну, как я уже сказал, есть еще вопросы и комментарии.
As I mentioned, there are further comments and questions in the chat. You can answer them in chat, please.
Так, следующий
Thank you for
доклад,
attention. So next
мой, совместно с
report
Антоном Кулаковым,
is mine together with Anton Kulakov. We are
«Русский алюминий».
working
Просто
in
сейчас я выложу
Russian
версию на английском языке.
aluminum company, and
для
I'll
одновременно.
make the English version of the presentation available.